Probability is simply the likelihood that an event will occur. It ranges between 0 and 1. So I'm going to talk about just 4 axioms of probability. Axioms are simply formulas. The first one is that probability must range between 0 and 1. The second one is that the probability of an event happening is simply the total number of those events over the sum total of the events. For instance, if we have 3 girls and 7 boys, the total number of people we have are 10. Then 3 out of 10, that is 30% of the girls, meaning the remainder is 70%. A complement is simply what is outside or what you don't have. So if the girls are 30%, the complement of the girls is 1 minus the probability of the girls themselves. So if the girls are 30%, meaning those that are not girls are what? Those that are not girls are 70%. So that's what it means, the complement. Then we have what we call Bayes' theorem. It's simply a pattern. So Bayes' theorem simply works under this algorithm. You drop this bottom guy here, then the top guy, usually we start with the alphabetical letter which comes first, A intersection B. All right. So if we had B given A, how do we expand this? Which guy goes down?
A.
A. Then what do we have on top?
A. B intersection A.
B intersection A.
B. It's the same A intersection B or B intersection A.
It's the same. Then we also have the union set. To unite is to do what? To add. This is the most faithful formula. It doesn't change. The prostitute formula is the intersection because it changes depending on what you are given. Who can give me the formula for A union B?
It's the probability of A plus the probability of B. Minus the intersection of A and B.
Minus the intersection of A and B, correct. All right. Then how do we know A and B are independent? What does it mean to be independent? To be unaffected by the one who's down there. So A given B must still be A. A given R must still be A. So meaning the top guy is maintained. That's what it means to be independent. All right. So if a given B given A, what must this one be equated to?
Probability of B.
B.
Probability of B.
According, I have a question. What's the difference between what you've written there and that one, this side, where is that one that is equal to the probability of the intersection over probability of B?
This one?
Like, isn't that A given B? And that one, and that one that you've written on the other side?
This is Bayes' theorem.
On top there, yeah. The one you're saying it's independent.
And this is a condition. This is just a condition. All right. A given B must be equal to A. B given A must be equal to B if they're independent. Then A intersection B must be equal to 0 if they're mutually exclusive. What does it mean to be mutually exclusive? If you have nothing in common, it means you're mutually exclusive. If you're always fighting with your boyfriend or your husband, just tell him to say, you and I are what? Mutually exclusive. All right. Are we together? So quickly,
Yes.
Yep.
I will draw a contingency table, which I'll quickly spend 3 minutes just explaining. Just get the concept here. You're given A, B xy. Maybe given 2, 4, 6, 8. The first thing you do is to get the totals. What total do we have here? 8. Here,
8,
12. Here,
12,
14. Here,
14,
6.
6.
And the total of totals here is what? 20. So the probability of A, I said, is the total number of A events over the sum total. So A is what? 8 out of 20.
20.
So what is B?
6.
6 over 20.
B is 6 out of 20. Do you agree?
Yes.
Yeah.
X. X. What is X?
12 out of 20.
12 out of 20. And Y?
It's 14 out of 20.
Out of 20. Okay. So what is A intersection B? Where they're meeting totals. Just draw a plus. Where are they meeting?
Two.
2.
2 out of 20. So where they meet out of the total of totals. How about X intersection Y?
8 out of 20.
8 out of
Which is 0.4. How about A given B? How do we expand this?
So probability of A intersection B over probability of B.
Okay. So what is our A intersection B?
0.10.
And B?
It's 0.3.
So when you divide that, you get 0.33. Can I teach you a shortcut?
Yeah.
So where they meet, but the total for the bottom guy. Where do they meet? A and B?
At 2.
2, but the total for B?
2.
The total for B is total for B is 6, right? Which is 0.33. With that shortcut, can you tell me what is B given A? 2 out of
2
what?
over 8.
2 over 8. 2 over 8.
Yes. This is 0. What? 0.25. You guys are just too busy. So what is A union B?
Probability of A.
Mm-hmm.
Probability of B.
Mm-hmm.
Minus probability of
A
A
intersection.
intersection B.
Okay. For A,
0.4.
B,
0.3.
and the intersection.
0.10.
What we get? 0.6. Okay, so quickly tell me what is X given Y? Somebody, what is Y given X? somebody, what is X intersection Y? Finally, what is Y X union Y? Quickly. What is X given Y? Please don't embarrass me. Anyone?
8/14.
8/14. Is she right?
Yes.
All right. About Y given X?
8/12.
8/12. All right. Then X intersection Y?
8/20.
8/20. Where they meet over the grand total. So the key thing is X given Y, where the bottom guy there. All right. Then what is X union Y?
Probability of X,
Uh-huh.
which is 0.57. Probability of Y minus probability of X intersection Y.
Okay. So just an issue of substituting.
0.57
And answer 0.57
plus 0.67 minus 0.4.
Okay.
0.84.
Then the other probability is to do with the trees. Suppose we're given that the probability of A is 0.4 and the remainder came from machine B. What is the remainder?
0.6.
0.6. Machines were found to be, items were found to be defective. And we're told that of those that were coming from machine A, those that were defective from machine A, they were 10%. So we say defective coming from A, 10%, which is 0.10. And those that were coming from machine B, those that were defective were 4%. Defective coming from machine B, 4%, 0.04. Now, I want to teach you what is called a posterior table, which summarizes the toughest probabilities. So there's this column which is called the prior probabilities. The prior probabilities always add up to 1. So ngamamona always add up to 1. Probability of A and B adding up to 1. These are called prior probabilities. So 0.6 and 0.4. Then you'll be given conditional probabilities, which we have here. So this is probability of D coming from A, 0.10. D coming from where? B. 0 point what? 0.4. Whenever you discover that this A is multiplying by the prior, this multiplication will just make the slash become an intersection. We call this a joint probability. So what we get when we multiply these two, it will be the probability of what? D intersection A. It comes from Bayes' theory. I repeat, using Bayes' theory here, you see A given B is equal to A intersection B over B. We are seeing that these are the same. Whenever you see these multiplying to each other, they make you get an intersection. So A given B times B, what does it give you? The intersection of the two letters. All right, A intersection B. So can you tell me, if I have X given Y, what do I multiply this one to get the intersection between the two letters? Hold on.
Probability of Y.
Y.
So I'll get X intersection Y. I'm just giving you tricks of probability. Then also the other thing you need to know that when you're multiplying, when you're adding two intersections, for instance, D intersection A plus D intersection B, the sum total will be the intersection, will be the letter which is common. Which letter is common here?
D.
This is called the probability of D. That's what the rules say. All right. So when I multiply these two, I'm getting 0.04. When I multiply these two, what will this be called? D intersection what?
Section B.
Which is 0.024. When I add these two, it will be the probability of what?
Of D.
Excellent. Which is 0.064. Okay. Now there's what we call a posterior probability. By the way, this carries 7 to 10 marks. When I divide this one over the top, it just makes this one a reciprocal. It becomes A given D. It just swaps that one. So when I divide this one divided by that, what do I get? 0.625. How about when I divide this by that, I'll get what? The probability of B given what? D, which is 0.025 divided by 0.064, which is 0.375. Okay, so anyone lost so far?
So which ones are you dividing?
Yes, on the posterior.
The last part, yeah, I'm equally confused.
So can somebody explain what did we do here? First of all, we're given this guy and that guy, this guy and that guy. How did we get this?
We're multiplying.
We're multiplying. Okay. So when we apply these two guys, we get D intersection A, D intersection B. The total here. How did we get this here?
We added.
Right.
Yes. Right. Then how do we get the 0.625?
We're dividing,
Uh-huh.
but with what?
So look,
So we are dividing the probability of
Oh.
A intersection D over the probability of D.
A given D is given by what?
Probability of D intersection A
Mhm.
divided by the probability of D.
Probability of D intersection A divided by the probability of what? Of D. All right. So is that telling us what we did there? So what are we dividing there? What did we divide?
0.04 divided by
0.06.
0.064.
Yes. Okay. Then even for the other one, we'll see what was happening there. So this is exactly what happened in the test. Now I need you to explain to me. This is how the question comes here. Suppose an item is manufactured by 3 machines, X, Y, and Z. All the 3 machines have equal capacity, meaning their prior probabilities are 100 divided by 3, equal. They should add up to 100, and are operated at the same rate. It is known that the percentage of the defectives are what? X is what? X, Y, and Z. Be 2, 7, and 12. These are conditional probabilities. Conditional probabilities don't add up to what? 100. All the items are produced by machines X, Y, and Z, and they're put in one bin. And one item is drawn and is found to be defective. What is the probability that it came from Y? So they're finding the posterior for Y. How many marks? It's supposed to be 7 marks in the exam. Maybe it's close to the test. So what do we do using this table? Let's identify the prior probabilities. So I want to make probability exciting for you. You need to apply the concept that I just taught you here. So the prior probabilities, what are the prior probabilities?
0.33.
Good, 0.33 or 1/3, because they're equal. We're told they're equal, right? So 1/3 for X, for Y it will also be 1/3, and for Z will be 1/3. If there were 4, what would we have been doing? 1/4, 1/4, 1/4, right?
1/4, yeah.
And what is the conditional probability for X? We say defective coming from where? X. It was what percent? 2%. Or 0. What? 0.2.
0.2.
Then defective coming from Y was what?
0.07.
0.07. And defective coming from Z was what?
0.12.
Usually the examiner will ask for only one thing, not all of them. What I did was for everything. So what we're interested in is in the Y. So here, what column are we going for? The joint.
Mid one.
So when we apply this and that, what are we getting? D intersection what? X. Ingapa?
Y intersection, D intersection Y.
Ingapa? D intersection what?
Intersection Z.
And
Z.
when I total up everything, what is it going to be called? The probability of what?
D.
Of D. Okay, I'm not interested in the answers, but what they're asking for is what? Suppose an item was selected random, what probability came from Y. So what they're asking for is to find the reciprocal or the posterior Y given D. Can somebody tell me how do we find the answer for Y given D? We total up the answers.
Probability.
We total up the answers there. We get R. So find this answer here. It is Y over what? R. That's all they're asking for, isn't it? All right.
Yes.
See how
Collins, are you going to post the video, this lesson?
yes, I'm going to post it.
Hello?
Yes, I'll post it. I'll post it. Am I breaking or you're because I'm hearing some network breaking? Am I also breaking?
Okay, we appreciate.
All right. So
Yeah.
that was just
Sometimes they're breaking.
Because when
okay.
network.
Okay, so we are done with partial probability.
Collins,
Yes, please.
Collins,
Uh-huh.
for the probability table. So is the table adequate, or there is we need to show some work in terms of how we are multiplying and everything like that, or just the table is adequate?
It's adequate. It's a table on its own. It's a formula on its own. It's adequate.
Okay.
All right. Can I proceed? So you see how interesting probability can be if you know the concepts.
Not when you're alone.
Not when you're alone. My people perished because of what? Lack of knowledge. Yeah. So the other one was to do with the random variables. Before I go to the ANOVA, if you're given the values of X as maybe 2, 4, 6, and the probability of X, maybe this is 0 0.3, 0.2, and 0.5. This is a probability distribution. So when you multiply these two columns, column X and the probability of X, you get the mean. So this by that is 0.6. This by that is 0.8. This by that 3.0. The total is 4.4. This is what we call the expected value. The shortcut for it is called E, not summation, E and an X like that. Or this is called the mu or average. So this is called 4.4. Then you go to square this, the X. So when you square here, you get what? 4. When you square this, you get 16. When you square this, you get 36. Then you multiply this square times the probability. So 4 times 0.3 is 1.2. 0.2 times that one, what we get? 3.2. And 0.5 times that one, we get 18. So when we add this, what are we? 4. So to find the variance, simply summation of x squared px minus a mean to the power 2, or summation of x squared px, because this is the mean to the power 2. So 22.4 minus 4 squared. What do we get? This answer minus the square of that answer is called the variance. What do we get?
$3.04.
0.04.
No, 3.04.
3.04. Then the square root of this one is called the standard deviation. Standard deviation, wherever you go, is when you square root the variance. So what's the square root of 3.04?
$1.74.
0.74. So finally, if they ask you what's the probability of x greater than 3, which numbers are greater than 3 here?
4 and 6.
So the probability of 4 and the probability of 6. So what's the probability of 4?
0.5.
And the probability of 6?
0.5.
And the total?
0.7.
Okay. Now this takes us to the test where we are looking at this. Petrol pump operator sells an average 80 worth of petrol on rainy days. Okay, and an average of 90 worth of petrol on clear days. Statistics show for the meteorological department that probability is 0.76 for clear weather and 0.24 for rainy weather. What is expected value? You should have even asked for the variance and standard deviation. Okay, so here, let's come up with this table together. We see how easy this is when you understand the concept. Okay, and almost of you were getting 100%, so credit to whom it may concern. So we now identify the value of x and the probability. So the value of x, we have what? 80,000
80,000.
and 90,000.
90,000.
What's the probability for 80,000?
0.76.
Because it was on a what? Rainy day. So we check for rainy day, you need to be very careful. 80 for rainy day. So rainy weather is what? 0.24.
24.
The remainder is 0.76.
76.
So how do you find the expected value or the mean? Multiply, right?
Yes. You multiply.
So what are you getting here? Are you getting here?
19,200 for the first one.
19,200.
19,200. Then the other one.
68, 4,000.
84,000.
400. 64. Yes.
4,400.
Yes, 00.
Okay. So what's the total?
8,400.
Mhm.
Plus
87,600.
Okay. I wish to modify this question for the sake of learning. How do you find the variance?
x squared times the probability.
Okay. So x squared times the probability, what are you getting? So square that times that.
In a million. 15
Mhm.
36,
Mhm.
then 6 zeros.
Okay. Then here.
Six one,
Mhm.
5 6,
Mhm.
6 zeros.
Okay. And the total.
Seven,
Mhm.
7692.
So how do we find? So meaning our mean. Our mean is called the expected value. So our mean is what?
87,600.
Okay, and what's the variance?
We do that one x squared of times the probability minus
If this is A,
uh
this is B.
Summation of n.
yes,
If this is A and this is B, how do you find it? This is A minus what?
B squared.
a minus b squared.
Good. What do you get?
One, 8, 2,
Mhm.
4, and 4 zeros.
And how do you find the standard deviation? Simply square root the answer, right?
Yeah, square root the variance.
Can you fail to find this, Shari?
It's confusing the way they bring the questions.
The questions come out confusing.
Yes, they come out confusing.
But it's the same concept, all right? Okay, so